We're going to do solving polynomial equations today. This should be a quick review right here about bumps and slides. Okay? So, A through F on page 96 of your student journal for Exploration 1. Work with your groupies there. Okay, so the quick hint for those of you struggling on this, focus on your y-intercepts. Okay, hey, we're going to go ahead and move on here. Letter A, notice, well, actually, I'm going to go this way. This has a y-intercept of 4. Okay, which one has a y-intercept of 4 up here? Actually, I'm sorry, 2. I guess we're going up by 1. Yeah, looks like C. It's the only one with y-intercept of 2, therefore, in this case, we've got letter C. Okay, and this one right here has a y-intercept of -2, which is letter E. This guy right here has a y-intercept of, looks like 1, which is letter B. Okay. This one has a y-intercept of, well, it's kind of tough to see, so let's skip that one. This one has a y-intercept of 0, but as does this one. Okay, there are 2 y-intercepts of 0. Which 2 have y-intercepts of 0? D and F. So one of those 2, I'm pretty sure this one's going to have the y-intercept of -8, which is letter A. Okay, the real point here, if you recall, when we talked earlier, we talked about bumps and slides. This right here, what happens at 1 when x equals 1? Yeah, it goes down and changes direction. So tell your neighbor what we can say about this function. So 2 of your factors are x minus 1, right? It has a multiplicity of 2 at 1. So that means here x equals 1 and x equals 1. It has to have an even number of multiplicity. Okay? Well, what's my other 0? -2. So this becomes x plus 2. All right? And then -1, and 2, when we multiply those together, we get our back term of 2. Okay, that would multiply out to be this. Okay? What happens when it slides? So if we go to C here, which is actually equation B, it was this one here, x cubed plus 3x squared plus 3x plus 1. Okay? This has, it's going to be a multiplicity of 3. It's going to be x plus 1 to the 3rd power. Okay, you get x equals -1 3 times. It has to be an odd number. We know it's not. It doesn't appear once because it slides. Can it appear 5 times? Just trying to remember everything we've done. Tell your neighbor why you can't have -1 5 times. Yeah, highest power is 3, right? It's cubic. You can only have 3 zeros. All right. Okay. How many recall doing that? Okay, we're gonna move past that now. So, want to make sure that we're good on it. Any questions before we move on? Okay, I want you to turn to page 99 of your student journal. Do a quick review of solving. I want you to work on these problems here. Okay? 1 through 6 up on the top. So page 99 of your student journal. Do your bestest there. Okay, I know you're not done, but I'm going to put up number 1. Tell your neighbor what you got on number 1.
R times R minus 6R minus 1.
All right, since it's set equal to 0, let's try to factor it. So I can take an r out of each of these. That gives me 36r squared there and -1 there. Whenever you have a binomial, look for difference of 2 squares or cubes or sum of cubes. Okay, in this case, this is a perfect square, that's a perfect square, and that's a perfect square, and we have a difference sign. So this piece right here factors into 6r minus 1 and 6r plus 1. And so if we solve, here, r equals 0. Here, we're saying 6r minus 1 equals 0, so that means r equals, we add 1 and divide by 6, so r equals 1/6. And here, 6r plus 1 equals 0. So we subtract 1 and divide by 6, so r equals negative 1/6. Okay. So we get r equals the set 0 and plus minus 1/6. Okay. If you have questions on it, make sure you ask. Okay, it looks like a lot of you are getting close to being done with number 2, or at least got a good start on it. So on this one, I'm going to set it equal to 0 first. So I'm going to rewrite it as 20x to the third plus 80x squared, and then I'm going to add that 60x over. So it's all equal to 0 now. So that became that. Now from there I can take out 20x. Okay. It gives me an x squared. From there it gives me 4x. From there I get 3. How many made it that far? You're good. This part, can I factor it? Yeah. It becomes x plus 3 and x plus 1. And then I have my 20x. This 20 times what is 0? 0. What plus 3 is 0? Negative 3. And what plus 1 is 0? Negative 1. So x equals that. Again, as I'm walking around, ask questions if you got them. All right, number 3, let's set it equal to 0. So 3m, oops, let's do this. Let's go 0 equals 75 m to the 4th minus 3m squared. Okay, so that becomes that. We then factor from there. We can pull a 3m squared out. Gives me 25m squared and 1. This is a perfect square, or excuse me, difference of 2 squares. So that becomes 5m, square root of that, square root of this, and then same thing but with a plus sign in between. We bring our 3m squared down. 3 times what is 0? 0. There's actually 2 of them because of the m squared. 5m minus 1 equals 0, so 2 steps would be to add 1 and divide by 5. And 5m plus 1 equals 0, the 2 steps would be to subtract 1, divide by 5. So our solutions, m equals 0, 0, and plus minus 1 over 5. Remember, the multiplicity just means that, well, tell your neighbor what it means is going to happen here on your graph. Okay, so remember, that's going to bump right there. It's going to change directions. Any questions on 3? Try number 4. I'll be walking around. Keep asking. Hey guys, I know we've talked about this a few different ways, but remember, this is anytime you look at your powers, if this your leading power is twice this one, you can think of it as y squared squared. Okay? And that becomes 13y squared to the first plus 36 equals 0. So You think of it that way. The other way to think about it is you could just say, well, y squared, I'm going to say y squared is actually x. Thank you. I'm going to say y squared is actually x in this problem, which means wherever I have a y squared, even if you didn't write it like this, you could say, well, okay, y squared, I'd have to square x to get y to the fourth. Okay, so I could write it as x squared minus 13x plus 36, and then factor that. Okay, and when I factor that, I get x plus, oh, it'd be x minus, thank you. Okay, x minus 9 and x minus 4 equals 0. Okay, but we know x isn't actually x, it's y squared, so we have to plug that back in. So we call that y squared minus 9 and y squared minus 4 equals 0. Okay, now the key there is looking at those two things. Those are both difference of two perfect squares, right? This becomes y plus 3, y minus 3. Kind of out of room, I'll write it here. Y plus 3, y minus 3. This becomes y plus 2 and y minus 2. Reality, it says solve. You could have just set them both equal to 0 and solved using square roots rather than factoring, but either way, what minus or plus 3 is 0, negative 3. What minus 3 is 0, positive 3. What plus 2 is 0, negative 2, and what minus 2 is 0, positive 2. So our solutions, y equals plus minus 3 and plus minus 2. How many got it? Bit tougher, right? You guys are getting into some complex factoring. Any questions? Sounds good? Okay. All right, let's take a look at the next one. Number 5. If you haven't started it, get a good start on it now. All right, what pattern are we using on this one? Anyone remember the name? Factor by grouping. Okay. So when I bring that 1 over, I am now trying factor by grouping. Always try that with the 4 terms. If it doesn't work, then we'll go through another process. But here, and I can group any of them. If I group this one and this one, that's what I'm going to try first. And then I'm going to try grouping this and this. Okay? And so, really, if I'm going to do that, I need to rewrite that minus 2x. I'm going to put plus, and then negative 2x, and plus 1 there. And negative 1, I'm left with 2x minus 1. So now I have the same groups. How many made it that far? Very good. So the group that I can take out is 2x minus 1. That's the thing they have in common. Then I'm left with x squared minus 1. That goes in my next set. This part is difference of 2 squares. X plus 1, x minus 1. This is 2x minus 1. What makes this 0? 1/2. We add 1 divided by 2. What makes this 0? So x equals 1/2 and plus minus 1. How many of you got it? How many are done with number 6? Who has started 6? Okay, how many are either done with 6 or stuck? Okay, how many are still working through it? You're like, okay, let's give you another minute here to work on it. Get as far as you can on it. Okay, how many made it that far? Alright, now if I try to group these right here, that would be my next step because I can't pull anything out. And when I try to group that, I'm going to start doing this little step in my head here. What can I take out here? Yeah, 4c squared. And if I take out 4c squared, I'm going to get plus 5. Now, if I want to get 2c plus 5 over here, okay, the first thing I'd want to do is group this, and I'd have to make this a plus, and so we have that, and I could take out a negative, what, a negative 5? Negative 25, thank you. Negative 25, and that gives me 2c and plus 5. Cool? How many got it? Okay. And so from there I get 4c squared minus 25 and 2c plus 5. Right? This is the piece they have in common. That goes here, and then I'm left with 4c squared and minus 25. This is perfect square, or excuse me, difference of two squares. So 2c minus 5 and 2c plus 5. And then we bring down that 2c plus 5. We end up with 5 halves for this one. Negative 5 halves there and negative 5 halves there. I'm just going to call it there. Okay. Any questions? All right. I want you to go back and take a look at your student journal. I want you to glance at this on page 98. 98 talks about the rational root theorem. And really all the rational root theorem says, this is some big kind of mess. This is a messy way of saying, hey, I've got a polynomial. That's all it's saying. It's saying, look, you have, this is your coefficient of x to some power. So, like if you wanted to make something up, you could actually, in fact, if we wanted to make something up, let's go ahead and use a problem. Look in your student journal on number 11 on page 100. Let's use that problem to talk about the rational root theorem. Okay? Number 11 says, according to the rational root theorem, which is not a possible solution to the equation? Well, the rational root theorem says this. It says that if I am going to have a number that goes into this, first you could trifactor by grouping, but if I'm just wanting to see which of these things is a possible solution, it says, the rational root theorem says, if you take the positive and negative values, or the factors of your back term, okay, so in this case, your in term. In your book, they call that your P, okay, or excuse me, A sub 0. Okay, that's your last term. You take all the factors of, in this case, 7, and divide it by all the factors of your leading coefficient, which they're calling in your book A sub n. Thank you. So my leading coefficient in this case is 2. Okay, my solution has to be a factor of, they're calling that P and that Q. So the factors of 7 are P and the factors of 2 are Q. Okay, my solution has to be P divided by Q. So in other words, any factors of 7, in this case, what are the factors of 7? 1 and 7. So you could divide 1 and 7, you can divide 1 by, well, there's only 2 factors of 2. 1 and 2. So all your possible solutions, I want you to list out all possible solutions you could have there. Okay. 1 over 1, negative 1 over 1. You could have 7 over 1 and negative 7 over 1. You could have 1 over 2 and negative 1 over 2. And you could have 7 over 2 and negative 7 over 2. Which one doesn't work? D. That's the rational roots there. Okay? That's all that's saying. All right. I'm going to pause there.